we're Running Robots Invent team located in Palos Verdes, California. We're a group of young inventors dedicated to solving modern-day issues. My name is Annie.
My name is Nolan.
And my name is Samantha. The problem we hope to solve is beach pollution. This can lead to detrimental effects on aquatic life and ecosystems. We live near the beach, so we can really see firsthand how much litter there can be.
We did research on how beach pollution can affect oceanic ecosystems as well as ways we could solve them. One topic we researched was water pollution. We found that 60% of over 4,000 beaches across the United States have unsafe pollution levels, and it is estimated that there are 5.25 trillion pieces of trash in the ocean.
To solve the issue of beach pollution, we decided to create a solar-powered beach cleaning robot. The robot uses solar energy for power, tank transfer, efficient maneuverability, and an Arduino-operated system to control the robot and to connect it to a compatible app, and a scoop mechanism to collect the trash. Furthermore, the robot's outer shell will be made out of recycled materials the robot has retrieved, making it more eco-friendly.
We wanted to make our robot look aesthetically pleasing without making it seem intrusive. After many sketches and designs, we decided that a turtle-shaped robot would be best fit for our idea. The design will also send a message that turtles are one of the main species that face consequences due to litter on the beach, and to keep them safe, people need to throw away their trash properly.
Before encountering the problem with beach debris, our team was researching other problems our society faces. One of them was a lack of popularity of solar energy. As we began to design our solution to beach pollution, we thought that it would also be beneficial to use solar panels as they are more eco-friendly. This would also be more efficient as our robot would be located in a sunny area, further increasing its ability to collect power.
Our robot will be using tank treads in replacement for wheels. This will allow us to maneuver over large and small hills and to stand more effectively than wheels would by providing more traction. As a result, we will be able to save electricity and push a larger load, as well as being resistant to unpredictable weather such as wind and rain.
We wanted to take it one step further and make the shell eco-friendly. To make the shell eco-friendly, we had to take the recyclable materials collected by our robot and use that to make the shell. We did this with a vacuum former that we currently have.
Our scoop mechanism allows our robot to easily collect trash while filtering out sand. The scoop has a rigid frame, making it sturdy and durable. A mesh net covers most of the mechanism, allowing sand to easily go through it while trash and debris get caught in the net. The robot is designed to push the trash towards a trash can nearby so we can conserve power.
We decided to add a camera to our turtle. The camera would use vision sensing to see its surroundings. This would use neural training and vision detecting algorithms to avoid people, obstacles, and the ocean, which would help our robot differentiate between trash and sand-dwelling creatures.
We wanted to make the user of our invention have full control over their turtle, so we created an iOS app that controls the turtle through Bluetooth connection. This app also allows the owners to name the turtle and control its movements. Owners can also view all of the robot statistics such as battery percentage, current load, and the amount of trash it has collected. With our About page, users can see who we are and read about our mission to keep beaches clean. So we have the app on a phone over here, and make the robot drive a specified path.
We found that there's a solar-powered beach cleaning robot already on the market, but this robot is not fully solar-powered, is extremely large, and costs several $1,000s. Our invention is different from this robot because it is fully solar-powered, cost-effective, much smaller, and is targeted to trash and debris on the beach. Also, we researched trash collecting mechanisms for the beach similar to a mesh net connected to a frame that people dragged along the beach to collect trash and debris. We wanted something similar to this, except our trash collection would be on a robot that runs autonomously.
So, as inventors, we always try our best to follow the design process. One of the most important parts of the design process is brainstorming. Shown here on the screen are some of the first ideas that we had for our invention.
Here are some pictures of our first prototypes. We created one to demonstrate what the shell would look like, one to show how the treads would work, and one that's shown here that combines both the shell and the treads. Throughout our invention process, we have encountered some issues on how to design our prototype and final build. For example, when we first printed our CAD design for the first iteration of the shell, the angles of the turtle shell were much too small for the panels to be placed on, so we had to redesign the shell, shown over here. We also learned how to vacuum form the shell, and we were able to mold plastic into our desired shell shape.
We tested how our robot would perform in sandy terrain and in retrieving trash. Our tread design and scoop mechanism would allow for effective movement and ability to retrieve trash. Additionally, we participated in local and state conventions to get feedback on our design. They shared the results with us, and we improved on our invention to do better in places that we were lacking. We also tested the efficiency of solar panels depending on the angle they were placed. We observed that the steeper they were placed, the more efficient the solar panels were, and were roughly twice as efficient as ones lying flat.
For our prototype, we used 2 servo motors, an Arduino board, 5 solar panels, and Vex Robotics manufactured parts. We all participated in Vex Robotics, so we didn't have to spend any extra money on the motors and the metal parts. The solar panels cost about $25 and the Arduino board costs a bit less than $5. Overall, we spent roughly $30 in developing our prototype. We also calculated how much power our prototype would need, and with the details from the motors, battery, and solar panels, we estimate that we will be able to run it for roughly 6 hours if we charge it for 10. We plan to make our robot much larger so it can collect more trash.
Our invention has potential to be used by many people, including environmental activists, beach authorities, and even larger corporations. This invention would be helpful because it's able to effectively clean the beach through environmentally friendly means. While creating and researching our invention, we learned about circuits, batteries, and solar panels, and refreshed on skills such as soldering and app design. In the future, we hope to get a patent on our invention and bring it to market someday. I hope you enjoyed our presentation, and thank you so much for listening.
Thank you.
Thank you.